All right, everybody. In this video, we're talking about special right triangles. So let's dive right in. Special right triangles, there are two types, and they have patterns to them, which is what makes them special. First type we have is a 45-45-90 triangle. Lower right angle. The way that the hypotenuse is related. Just a little justification for why this is. Let's plug in values in this 45-45-90. Let's say this is a length of 2, and this is a length of 2. If we use Pythagorean theorem to find the hypotenuse, we're going to get 2 squared plus 2 squared equals c squared. That's 4 plus 4 equals c squared, which is 8 equals c squared. Take the square root of that. To simplify the radical that is square root of 8, we'll make a factor tree. There's a 4 and a 2, a 2, which means a pair of 2's, which makes that c ends up equaling 2 root 2, which you'll notice is the length of one of our legs with an additional root 2 next to it, multiplied. So that pattern will always exist in 45-45-90 triangles. Those are right triangles that basically have two legs that are the same length, which kind of makes them special in another way. One leg that's longer than the other. Put into words, we can say that the long leg is equal to the short leg times root 3. And the hypotenuse will always have a length of 2x. In other words, twice the size of the short leg. So the other equation important here is that the hypotenuse equals short leg times 2. And you can do a proof that's similar to the proof for the first one that we did using Pythagorean theorem. If we said that there was a 30-degree side with a length of 5 and a hypotenuse with a length of 10, and you used Pythagorean theorem to find x, you would notice that it would be 5 root 3. I'll leave that to you to do if you want to, but it will work. So, how does this come into play in problems? Well, first of all, you want to make sure that you're using simplest radical form. Let's put a little bit more notation in here, and we'll say that this is a right triangle. If that's the case, for this one, and we're looking for the missing sides, if those two lengths are the same, this has to be a 45-45-90 triangle. So, if that length over here is 12, that means that this one down here is 12. And using one of our equations, we know that in the 45-45-90 triangles, the hypotenuse is any of the leg lengths times root 2. So our leg length in this case is 12, which means that the hypotenuse is going to be 12 root 2. Simple as that. And then we have all the lengths for this one. Not too bad, right? So let's turn this one into a 30, 60, 90 triangle. We'll say this is a 30-degree angle over here. And the hypotenuse. Well, one of the formulas that we have for 30, 60, 90 triangles is involving the hypotenuse. One of them is hypotenuse equals short leg times 2. Well, let's plug in the value that we know, which is the hypotenuse. Then we know that 12 equals the short leg times 2. If we divide both sides by 2, we get that the short leg has a length of 6. Remember that the short leg is always the one across the triangle from 30-degree angle. And from there, this problem's not too bad, because we know that to find the long leg, we need to take the short leg and multiply by root 3. Well, that means that we're going to take 6, which we just found out was our short leg, times root 3. So what we're going to do is we're just going to put that down here. And there it is. That one is done. So now we're going to move to an example that's a little bit tougher. We're going to say that this is a 45. So this one's a little trickier. It's because it's going to involve dividing by square roots, and then because we have a square root denominator, we need to rationalize it, which you got a little practice with in your simplifying radical practice. Here's why. In this case, we're still going to be using the formula, the only one we have for 45, 45, 90s, but what it's going to be this time is we know that the hypotenuse equals the leg times root 2, but this time we know the hypotenuse. We know that this is going to be 7 over here equals leg times root 2. Well, what we're going to need to do then is to get rid of that to find out what the leg is. We need to divide both sides by root 2 to make these cancel out and get leg by itself. But when we do that, we create a radical in the denominator, which we need to get rid of. So what we're going to have to do is that process that we learned about or remembered about earlier, last week. So what we'll have to do here to get rid of this root 2, just to remind you, is we need to multiply both the top and the bottom by root 2, which is going to give us 7 root 2 over 2. And that would be leg length. And when you have a 45, 45, 90, good news is, so we're going to say this one's a 30, 60, 90 triangle. The 60, the one across from the 60-degree angle, that's the long leg. Formula for the long leg, remember, is that it's the short leg times root 3. So you can see we're going to need a similar process for this one to what we did in the last example. We know that 15 equals the short leg times root 3. So we have to divide both sides by root 3. Divide by root 3. Those cancel out. We need to rationalize this. We have 15 root 3. And remember to rationalize, we multiply the top and the bottom by root 3, which is going to give us 15 root 3 over 3. 15 divided by, we can do 15 divided by 3 to simplify this, which will turn it into root 3. Now remember, that's giving us the short leg. So that means that over here, actually, from here, finding the hypotenuse isn't so bad. Because the hypotenuse is 2 times the short leg, which we just found to be 5 root 3. 2 times 5 root 3 is a pretty simple calculation. Only multiply the 2 and the 5 to get 10. And that is the answer. So, that is how you handle simplifying radical problems. Hopefully you found this video helpful. We'll talk about it later.